Assalamu alaikum. Myself Sid Usama and my roll number 21TE09. Here is I am going to explain the DSP Lab 3, which is analyzing discrete time, linear time invariant. Here is the lab 4, analyzing discrete time, linear time invariant. The objective of this lab is to analyze discrete linear time invariant system. In task 1, how would you differentiate between a signal and a system? Explain the key characteristics of each and provide examples of illustrate their roles in the context of signal processing. Solution. In signals, the signals can be categorized as continuous time or discrete time or deterministic or random. Example including analog audio signals, digital image and EEG signals. Systems. Systems can be linear or non-linear, time invariant or time varying, and casual or non-casual. Examples include filters, digital signal processors, and neutral networks. In summary, signals and systems form the foundations of signals processing, where signals convey information and the systems manipulate these signals to achieve specific objective in diverse fields like communications, image processing, and control system. In task B, how do linear time invariant systems play a crucial role in digital signal processing? Considering their mathematical simplicity adherence to superposition principle, efficiency in frequency response analysis solutions. Linear time invariant systems are crucial in digital signal processing due to mathematical simplicity. Their linearity and time invariance properties simplify analyzing and implementations. Point 2. Superposition principle. They inherit to the principles allowing easy decompositions and processing of signals. Point 3. Efficient frequency response analysis. LTI systems have a well-defined frequency response, facilitating efficient design of filter and analyzing of signal behavior in the frequency domain. The characteristics make LTI systems foundations for various DSP applications, from the telecommunications to audio and image processing. In task 6, what are the common methods for signal decompositions, specifically focusing on techniques like impulse decomposition, step functions analyzing, and even odd decompositions and Fourier analysis. Explore how this method contribute to breaking down the signals and their applications in signal processing. Solution. Signal decompositions method are pivotal in signal processing, offering ways to simplify and understand complex signals. Here a deeper look at some common techniques. Impulse decompositions represent signals as a sum of impulses, useful for understanding system responses to sudden changes or impulse aiding system analysis. Step 2. Step function analysis breaks signals into step functions, helpful for studying transient behavior in system, allowing engineers to understand response to abrupt input and design a best control system. Point 3. Even odd decomposition separates signals into even and odd components, with the even parts representing the signal symmetric component and the odd part represent the antisystemic components. It's a valuable for noise removals, enhancing signals quality by isolating desired signals from noise. Fourier analysis decomposes signals into sinusoidal components using the Fourier transform, reveal, revealing the frequency content of the signals. It widely used in tasks like filtering, modulations, compressions, and spectral analysis, aiding in various signals processing applications. These methods have broad applications across diverse fields such as telecommunications, audio processing, biomedical, signal processing, and control system. By leveraging signal decomposition techniques, engineers can efficiently analyze, manipulate, and extract relevant information from signals, leading to advancement in technology and applications across various industries. Task D. What is convolutions and how does it play a significant role in digital signal processing systems? Explore the fundamental concept of convolution, elaborate on its importance in various DSP applications such as filtering, signal processing, and analyzing. Solution. Point 1. Convolution combines two signals to produce a third fundamental in DSP. Point 2. Vital and filtering modifying frequency content for noise reductions and signal enhancement. Point 3. Used in tasks like smoothing edge detections and fetching extractions in signal processing. Point 4. Predict system output for any input in system analysis, aiding designs and optimizations. Point 5. Essential for diverse DSP applications including telecommunications, audio processing, image processing, and control system. Task key. What do we correlate to signals, and what are the key applications or scenarios where signal correlations is crucial in various fields such as communication systems, radar and sonar, image processing, biomedical signals processing, control system, wireless communications, and seismic signal processing. Solutions. Signal correlations involves measuring the similarities between two signals as a function of a time shift between them. It is used when comparing signal to find pattern, determine relationship, or synchronize data. Here are the key applications or scenarios where signals correlation is crucial across various fields. Point 1. Communication system synchronizing transmitter receivers, aiding in channels estimations. Point 2. Radar and sonar detecting and tracking target by distinct echoes from noise. Point 3. Image processing, aligning image for sketching, motion tracking, and object recognitions. Biomedical signal processing, analyzing ECG and EEG patterns for diagnosis. Task 1. Make your own customized functions that take two input signals from user and show convolution system for some graphically. Here you can see the functions of convolutions which we give the commands of a reference. First we take the functions result length and the paired signals convolution result, and then we give the commands of a subplot, plot, titles, and we give the labels of x and y. Here you can see the output of this lab of this task convolution sum of two signals. Task 2. Make your own customized functions that takes two input signals from user and use flip and slide method to show convolutions sum step by step. Hint: use pause command to stay and see stepwise convolution result. Here you can see the task 2 input. Here, here the MATLAB function based on your specifications. The signal take four arguments. First, result and convolution results, flip signals, and index starts. Here we give the different commands for this task input. Here you can see the output of this task 2. Task 3. Compute the response of the following system to the input. Here h, x, and the input of this task 3. The MATLAB function based on the specifications functions is y. The functions is hn, which is 2 3 minus 1 2 5 minus 4, and xn 1 minus 1 0 7 9 1 minus 1 4 2 minus 5 minus 1 0. That's we build a user defined functions for four arguments will be passed to the functions. Input xn information about its origin, impulse response information about its origin. The input signal x along with its information about origin and x. Impulse response h along with its information about origin and h. It computes the beginning and ending indices, the resulting convolutions, and it constructs the input index, that's vector and y, and it's perform the convolutions using MATLAB built-in convolution factors. Here, about after these convolutions, after the perform of the convolutions, here you can see the output of this task 3. Task 4. We have the impulse response of the system as n 3 2 1 minus 2 1 0 minus 4 2 0 3 for nx, and then we find y and if we feed shifted versions of input signals. Here you can see the input of this task 4. To find the input signals y and we will use the convolution operations that donates the impulse response as h the hn and the input signals, and then xn the output signals, and yn can be computed as the 0 1 length. By using the MATLAB functions myconvey, we can compute the functions we can compute the functions, and then you and then compute then and then we computing the same functions myconvey passes these shifted signals and its origin information. The specific output signals would depend on the nature of this system that described by the impulse response of this input of this task 4, and then we define the different functions as x shifted, y shifted, and subplots, stems, titles, and for this input. And here you can see the output of these signals: input signals, impulse response signals, output signals, shifted impulse signals, output signals for shifted input. Thank you very much. This is all from my side. Allah Hafiz.